Hey, good morning, students. Today we're going to be looking at polygons in the coordinate plane. So that's going to be rather interesting. We're going to be looking at how to graph them in the coordinate plane, but also how to identify what they actually are. Is it a square? Is it a trapezoid? Is it a triangle? If so, what kind of triangle? All those things we'll answer today. And also, we are going to be using a software called Geogebra Classic. So we'll talk about that in a moment. I first want to state when you're graphing polygons in the coordinate plane, they are defined by what we call vertices. These vertices are the points where the sides of the polygon intersect. And each of those, when they intersect, form a point. So what we'll be doing is we'll be graphing a set of vertices, that's plural for vertex. And so we'll take a group of those, we'll plot them, and then we'll analyze the shape that is formed by connecting adjacent sides of the polygon. So let's switch to our desktop and we'll open up the Geogebra Classic app. So on your laptop, I want you to open up a browser. And we're going to go to the website. It's called geogebra.org. Geogebra.org. And you could go up here to start graphing, and that is actually a graphing calculator, but there are some other features on GeoGebra that I would prefer to use, and that is actually under the GeoGebra Classic software. The Classic was my first experience with GeoGebra, and I fell in love with it. I love Desmos Graphing Calculator. It is wonderful also, but as far as doing geometry in the coordinate plane, GeoGebra is it. It does some amazing things, and we'll be using it in this lesson and also in another where we look at polygons in the coordinate plane, but in particular how to find the area and perimeter of that polygon. So if you click down here on the GeoGebra Classic link, it's listed under more apps. You have several here: notes, geometry, GeoGebra Classic, and probability. So if you click on GeoGebra Classic, it will open up the Classic view. And over here on the right, you can just say graphing. That's okay. It does allow you, if you want to save your work, to come up here. And I could log in. I could sign in. But I'm not worried about saving our work today. So I'm not going to do that today. But you could sign in if you choose. And then the work that you do in GeoGebra will be saved for you into a file, which you could open later. But our first problem, we want to graph our first set of points. And those points are given by a polygon defined by the vertices 0, 0, 3, 0, 3, 3, and 0, 3. So what we want to do is take each of those points and graph those. So we have a coordinate plane here, which, by the way, if you were on the pointer tool over here in the upper left, then if you have a scroll mouse, you can zoom in or use these zoom buttons or functions down here in the lower right. But I like kind of grabbing and moving my coordinate plane around and just zooming in. So we know we're going up to 3, so that should be good right there. And now if I want to plot a point, which is what we're wanting to do, then we're going to go over here and select the point tool. Okay? And what we're going to do is we're going to come down here, and our first point was 0, 0. So this is 0, 0. This is the origin of our coordinate plane. So we're going to click right there, and it's going to plot the point. It will also put the point over here in the upper left. And I'm going to zoom in on this so hopefully you can see that just a tad bit better on the video. And let me delete that point. If you accidentally click on a point like I did, I wanted to move my coordinate plane, but I didn't click on the pointer tool first. Then all you have to do is click on these three dots and hit delete, and it will remove that point. So I'm going to click over here, and then I'm going to slide this over. Okay? About right there. Now our next point, if I click back on the point tool, then I am going to plot the next point, which is 3, 0. 3, 0 is located on the x-axis, is right here. And you're going to locate that point and click on it, and you can double check that is indeed 3, 0. And then we have the point 3, 3. So we're going to go from the origin, right 3 on x, and then up 3 to this point here, and we'll click there. And that is point C. It's nice how GeoGebra labels each of the points also. But now we have 3 of our points, and our final point is the point 0, 3. And most of you should recognize that from our work with linear equations, that that is indeed on the y-axis. Okay? So we're going to go to 0 on x, and we're going to go up to the point 0, 3, and we're going to click on that point. And now we have 4 points, all 4 vertices of this problem that we've graphed. And it's starting to look like something. I hope you guys are starting to recognize it. But we don't want to assume that it is what we think it is. We want to actually prove it. So what we're going to do is we're going to take and use some other tools on here. The next one will be this tool right here. It looks like a triangle in the menu button that's shaded in. That's our polygon tool. So what we're going to do is we're going to click on this button and choose polygon. And then what we're going to do is we're going to take each vertex and we're going to click on them and go all the way around in order. Doesn't matter what direction I go. But if I click here, I'm going to go to point B and click on that point. Then I'm going to go up to point C. I'm going to click on that point. I'm going to go to point D. I'm going to click on that point. And then back down to our starting point, which is A, which you can see is shaded here in black. And then click on that, and it will close the polygon. Now, the thing that immediately happens in GeoGebra is it actually calculates the distance of each of these line segments. So this distance A right here is a segment of 3 units. So it's 3 units in length. This segment B over here, you can see, is 3 units as well. Segment C right up at the top of our polygon is also 3 units. And D, well, that's on the left here. The left side of our polygon is also 3 units. So if I were going to mark this mathematically, I could do so by coming over here and choose the pen tool, and I could mark this as a congruent side to this. These sides are all congruent, so I can mark them with a single tick mark, and that tells me that each side is congruent. They all have the same measure. Okay, so we'll put a single tick mark on each of those. Okay. Now, the last thing I want to show you on analyzing this polygon is to look at the angles. Now we can tell it has side measures that are all equal, but it doesn't necessarily tell us that it's a square. It could be what we call a rhombus or a diamond or something. So we want to look at the angle measures. So in Geogebra Classic, it also has an angle measure tool, which is located right here. And if I click on that and go down to angle, then I'm going to measure each of these angles. Now I do want to tell you that the measuring tool, you want to move counterclockwise around the point or the vertex of the angle. Okay? If you move clockwise, it's going to measure to the outside of the square, so we don't want to do that. So I want to go from this bottom side up to this left side. So all you do is click on the sides of the angle about that point A. So I click on this side. It highlights the side, and then I come up here, I click on that side. And indeed, that is a 90-degree angle, which you would expect, obviously. You guys knew that. This is the intersection of the X and Y axis. Of course, that's a 90-degree angle. So over here, we're going to check this angle. But again, I want to go counterclockwise. So I'm going to click on this side, and then I'm going to come and click this side. Okay, and I get a 90-degree angle. So if I come up here and measure this, let's say I forget to go counterclockwise. And let's say I clicked on this side and then hit this side up here. Do you see what it gives us? It gives us the exterior angle. And that's not what I wanted. But again, I can come over here on the left. I can click on those three dots for that angle. And I can delete it off. And then say, oh yeah, I forgot to go counterclockwise. So I'm going to come up here. And I'm going to choose the top side first. Well, there you go. I'm surprised, but it just finished my angles for me. I was not expecting that. But we can see that each of the angles here, they're all 90-degree angles. So we have a polygon that has equal side measures. We have a polygon that has equal angle measures, 90 degrees each. They're all right angles. And another tool I could look at is the slopes, okay? And you guys remember slope of the line. So if I choose that, that's also under the angle menu, but you go down to slope, and all you have to do is click on the line segment, and this slope is vertical. You would expect that to be an undefined slope. So that says it's a vertical line. The opposite side also has an undefined slope. And if these are horizontal, then these two sides also have zero slope. Which tells me, and if I mark this mathematically, guys, and how you do this mathematically is you will come over here to our pen tool, and I can mark this right here that this side is parallel to this side. Okay, so all you do is put an arrow on the side, and these two sides are parallel, so I'm actually going to put two arrows, and I'm going to put two arrows over here. Okay, so what that tells me is I have a polygon where opposite sides are parallel. All the sides have the same measure, they're congruent, and I have 90-degree angles at my vertices. So guess what? This figure is a what? Did you say it? It is a square. Okay? I can write my R. Okay? So we have not just looked at it to say, yeah, it's a square. We actually proved it. We looked at the angles at each vertex. We looked at the side measures. We also checked that the sides are parallel. You know, the opposite sides are both parallel. So we have indeed proven that this is a square by definition. Okay? So let's move on to our next problem. And for that one, we're going to clear out our work here. So what you want to do is come over to these three lines and just hit new. And, you know, we don't have to save this. So I can just put don't save. I'm going to click on graphing. And now I want to close this. And we are going to plot the next set of coordinates. And for this set, I'm going to scroll in just a little bit. We are choosing the point tool. And for this problem, we have the 4 points 0, 2. So we have a polygon defined by the vertices 0, 2, 2, 0, 4, 2, and 2, 4. Okay? So if we plot these points, our first point is 0, 2. So I'm going to go to 0 on X. I'm going to go up to 2. And there you have it. Okay. The next point is 2, 0. Well, that is on the x-axis. And then we have the point 4, 2. So I go to 4 and I go up 2. And we're going to plot that point. And double check the coordinate over here. You want to make sure it's correct. And then 2, 4. So I go to 2 and I go up to 4. All right, some of you may again be thinking, hey, I know what that is. Well, let's check it. We're going to use the same process that we did on the last problem. So our next step is to take our polygon tool. We're going to click on that and choose polygon. And it doesn't matter which point you start at. I can start here at D. I can go around my figure in any direction, as long as I end up back at my starting point, and as long as I'm not doing opposite sides. I want to go each adjacent vertex, okay, and then back to the starting point. And when we look at this, I'm first going to check all my side measures, and before I do that, I'm going to zoom in on this a little bit. Okay, so there we go. There's our figure. And now I want to check the side measures A, B, C, and D. If I look at A, I have 2.83. Side B measures 2.83. Side C measures 2.83. And side D also measures 2.83. So we're going to come over here. And if I want to mark that, then I'm just going to put a tick mark on each of these sides, because I have shown that these are indeed congruent sides. Okay. And do you remember what our next step is? That's right. We can look at angle measures. So we're going to use our angle tool. And again, we want to move counterclockwise. So from this side to this side would be counterclockwise. So we're going to choose this angle and this angle. I get a 90-degree angle. I'm going to choose this angle or this side to that side. That's 90 degrees. This side to that side is 90 degrees. And this side to this side is also 90 degrees. So we have a polygon with congruent sides, and all the interior angles are 90 degrees. And the last thing I'm going to check is my slope on each of the sides. I should have opposite sides parallel. So we're going to come over here and look at slope. And all you do is click on the side. So I'm going to click on side A. That's a slope of 1. And it tells you right there m is equal to 1. I'm going to click on side C. That's m equal to 1 also. I'm going to click on side D. That's the slope of -1. And I'm going to click on side, let me go back to move and slide this up so you can see. Yes, side B also has a slope of -1. So what does that tell us? It tells us again that we have, and I can mark this, remember, we have opposite sides that are parallel. And we're going to mark that with an arrow on the side. Single arrows on opposite side tells you that those are parallel, and then I'm going to mark these as parallel using a double arrow. All right. So that tells me I have opposite sides parallel, and I'm so sorry. We have an undo tool up here. We're going to make stray marks. All right. So what we have here is indeed another square. All right. And again, we don't want to just say what it looks like. We want to justify it. So we want to analyze the angles. We want to analyze side measures. We want to analyze slopes of the sides to see if we have any parallel lines in the mix. And then once we've done our analysis, we can then declare what the polygon actually is. So let's look at our next problem. Again, when I want to clear my workout, assuming I'm not saving it, if I want to save it, I could screenshot it, but we're not going to worry about that right now. We're going to click on the 3 bars here, and we're going to click on New, and we're going to say Don't Save. Okay? And then click on Graphing. And here we are again. So I'm going to center up my axes. And this problem, I'm going to let you try. Okay? So we have the problem, a polygon is defined by the vertices 2, -3, 4, -5, 8, -1, and 6, 1. Okay? So if you want to pause the video right now, use Geogebra to plot those vertices. I'll put them on the screen here shortly. Plot those vertices and then do the analysis. Check the side measures, check the angle measures at each vertex, and also check the slopes of the sides. And then make your identification as to what this polygon is. What shape is it? So pause the video now, and I look forward to seeing your work. All right, so right now we're back. Hope you guys were successful in analyzing this. We're gonna click on the point tool and we'll see if we get the same answer. So we're looking at the first point, which is 2, -3. So this is 2, -3, and I'm gonna click on that point. And our next point is 4, -5. That's 4. And all the way down to -5. And then my next point is 8, -1. That's over here, 8, -1. And then I have the point 6, 1, which is right here. Okay? Now, the next step again was to use the polygon tool, which we'll click on that and choose polygon. And then we want to go from vertex to adjacent vertex all the way around our figure defined by these vertices and back to our starting point and click that to close the polygon. Now, what are we looking at here? Let's first come over here and move this in the display and zoom in so we can see what we're doing. Okay? All right. So if you look at segment A has a measure of 2.83, and if you look at segment C, which sits across from it, it also has a measure of 2.83. So I can actually tag those as being congruent. So I'm going to go to my pen tool, and I'm going to put a single tick mark on each of these. Okay? That tells me that these two opposite sides are congruent, which means they have the same measure. And now I'm going to look at side B and D. Side B has a measure of 5.66 and side D has a measure of 5.66. To mark those as congruent sides, we've already used a single tick mark, so we want to go to a double tick mark. Okay? All right. So now we have two pairs of opposite sides that are congruent. Okay? And our next part of the analysis is to come over here and use our angle tool. So we're going to click on that and choose angle. And we want to check the angles at each vertex. Okay? So we're going to go counterclockwise. So we'll click side A and side D. Well, almost. And then we're going to do side B, side A. And then we're going to do side C and side B, and then side D and side C. And if you notice, each of the angles is indeed 90 degrees. Okay? So we have opposite sides congruent. We have each vertex angle is at 90 degrees in measure, so they're right angles. And now I want to look at my slopes. I want to know, are the opposite sides parallel? Okay, so to do that, we're going to click on the angle tool again, but we're going to choose slope. And then I want to click on each of the sides to find the slope of the line. So this line has a slope of -1. This has a slope of 1. This has a slope of -1. And side D has a slope of +1. So if we mark that on our figure, which I can do that with a pen tool over here, then we know that each side D and B both are parallel. So we're going to put a single arrow on that. That tells me these opposite sides are parallel. And also side A is parallel to side C. Okay. Guys, the official way to write that is I could say that segment AD, and segment, you use a bar across the top, is congruent to, that's the congruent symbol right there, is congruent to segment CD. Okay. I can also say that side AD, segment AD, is parallel to, and I use the little parallel symbol, and that's to side, looks like BC. And in like turn, I could say segment AB is also parallel to side CD. Okay. And that's the official way of writing that. But guys, what have we seen here? We've seen that this polygon has sides that are opposite each other, that are both equal and parallel. We have right angles at each vertex. And what that tells us is that this is a parallelogram, but in particular, it is a rectangle. Okay? So if we look next, we're going to do another problem. But I want you to see each of the problems we've done up to this point have all had 4 vertices. They've had 4 sides. And we call those type figures a quadrilateral. That's their classification. We call that a quadrilateral because they have quad, which is 4 sides. So they have 4 sides each. So let's look at our next problem. To clear this out, we're going to come over here, click on the 3 bars, and choose New. Okay? And we're not going to save this. And let's click on graphing. Okay? So our next problem is a polygon defined by the vertices 6, 5, 1, 2, and 6, 2. Okay? So we're going to find those points on here. We're first going to click on the point tool and choose point. And our first vertex is located at 6, 5. So we're going to go to 6 and go up to 5. And then our next vertex is located at the point 1, 2. And our next vertex is located at 6, 2. All right. So I hope you guys are seeing what's forming here. Okay. So once I have this, I'm going to finish out my polygon using the polygon tool. And I'm going to go all the way around my figure. Just pick a starting point. It doesn't matter which vertex. Go all the way around and back to the start. And now we have our polygon. So I'm going to click on this, our move tool. I'm going to slide this down and zoom in so we can see what we're doing. And we know we have a triangle here. Okay? Not a problem. This is indeed a triangle. But identifying the polygon, sometimes it's important to state what type of triangle. So we want to look at that in particular. So what we want to do is we're going to do the same analysis. We do have side measures here, A, B, and C. Side A measures 5, side B measures 3. That's the legs of our triangle. And this 5.83, well, it could be a hypotenuse, but for that to be the case, we'd be talking about a right triangle. So what we want to do is make sure that our angle C here is indeed a right angle. So we're going to click on our angle tool. I'm going to come over here and make sure you're going counterclockwise. Click and click. And yes, indeed, we are looking at a right triangle. Okay? So that would be this type of polygon. So we'll say this one's a right triangle. This is not an isosceles right triangle because side A and B, one measures 5, one measures 3. So we can't say it's an isosceles right triangle. Is it a 30-60-90 triangle or 45-45 right triangle? Well, to do that, we need to look at the other angle measures. So we're going to come over here and do that. We're going to click here and here. We have 30.96 and this angle is 59.04. These angles are not congruent. Definitely not congruent. So this is not a 45, 45, 90 degree right triangle. That would be an isosceles right triangle. This one right here is almost a 30, 60, 90 triangle, but not quite. So even though it's close, this is not one of our special right triangles. Okay? So we'll just call this a right triangle. So our next problem, guys, we're going to go over here and clear this off. So we're going to click on New and Don't Save in Graphing. And our next problem, we're going to say a polygon defined by the vertices 2, -2, 5, 1, and 8, -2. Okay? So that's what we want to look at now. Okay? So let's look at those points. We're going to click on our point tool and we're going to plot our first point at 2, -2. This will be 2. Oh, did not mean to do that. Now I can't move that. There we go. Delete that. 2, -2 is right here. And 5, 1. We're going to go to 5, 1. And then we have another point, 8, -2. 8, -2. Okay. So it looks like we're looking at a triangle again. This is going to be a 3-sided polygon. So we're going to click on our polygon tool. And we're going to go all the way around our figure. And back to the starting point. And then I want to click on my pointer tool and I want to zoom in on this so we can see better what we're doing. And we'll center that up a little bit. And now we want to do our analysis. Now the interesting thing is if I look at sides A and C, I can see that this is a 4.24 measure and this is 4.24 measure. So what does that tell you? Well, it tells me I have 2 congruent sides on this figure. So I'm going to go to my pen tool. I'm going to say that this side is congruent to that side. Okay? So that's something that we definitely know to be true on this figure. And I want to come over here and click back on pointer. And so I can tell you indeed that this is an isosceles triangle, but is it any other type triangle, that any other characteristic that makes it special? Well, we have to do our analysis for that. So we want to look at our angle measures. So we're going to come over here and we're going to click on angle. And we're going to go counterclockwise. So that's a 45 degree angle. Wow, that's looking good. Ah, did I go counterclockwise? Nope. So I'm going to delete that off and make sure I go counterclockwise. So I have 45, 45. So can you guess what this one is? I think you can. That is a 90 degree angle. So this is actually our special right triangle, a 45, 45, 90 degree right triangle. It's also an isosceles right triangle. So it's an isosceles right triangle, all right, which is a 45, 45 degree right triangle, okay? So anyways, let's do our last problem. This is problem number 6. We want to clear out our work. So So we're going to do new and don't save. And this will be it. Our last one. Okay. So if you guys want to try this one and see how you do, that would be great. Do all the analysis, look at sides, look at slopes. We didn't look at slopes on the triangles because we didn't need to. Those were looking mainly at the angle measures. But this next one, you may want to look at slopes. It's another quadrilateral. It's a polygon defined by the vertices 2, 0, 5, 2, 3, -3, and 9, 1. Okay? So you want to come over here. Well, you're going to start out by choosing the point tool. And then you will lay out your vertices. Use your polygon tool again. Draw out your polygon. Then you want to go in and look at the side measures. Can you see anything of interest there? Then check the angle measures. Anything interesting there? And then finally, do you have any parallel sides at all? So that you would look at your slope, which is under the angle tool. So you guys pause the video and try this next problem, and then we'll come back together and see how you did. All right, so you guys have had time to look at this problem. So we're going to start by plotting the points of this polygon, the vertices. The first is at 2, 0. So we're going to come over to 2, 0 and plot that point. Our next point is at 5, 2. So we're going to plot that point. And then we are at 3, -3, which is right here. And our last point is at 9, 1. Okay. So this is an unusual looking shape. Definitely unlike the ones we've plotted already. So we're going to close out our polygon. So click on the polygon tool and choose polygon. And it doesn't matter what order you do this, but just go all the way around your polygon. And close it off. Now, we said the first part of the analysis was to look at side measures. We have side A measures 3.61, side B measures 4.12, side C measures 3.16, and D measures 7.21. There are no congruent sides in this figure, so nothing of interest there. So all I can say right now is this is indeed a quadrilateral, but what type, we're not sure. So we'll continue our analysis. I'm going to look at angle measures, okay? And to do that, I'm going to zoom in a little bit here for a second. There we go. And we're going to click on the angle tool. And remember, to measure the angle, make sure you're going counterclockwise. That would be clockwise, so I want to go this direction. Yikes. So 105.26. And then I'm going to go this direction. 132.27. Not the same. This next angle D is 47.73. And this next angle is 74.74. Wow. No congruent angle measures. So we didn't learn a lot there. But we have one more tool, right? One more thing to check. We want to check the slopes of the sides, okay? So for side C, I'm going to click on that. And what type slope do we get? Let me click on the pointer tool and slide up. We get a slope of -3, okay? Not bad. And then I'm going to choose my slope tool again and click on side D. That slope is 0.67. Okay, not the same. This next side, side B, has a slope of -1/4 or -0.25. And then our last side, side A, well, it has a slope of 0.67. Uh-oh. So we have something here. We have side D and side A have the same slope. And remember, two lines that have the same slope are parallel. So we're going to mark these two sides as parallel to each other. So we have a quadrilateral with a pair of opposite sides that are parallel. And what do we call that figure? Well, it's not just a four-sided figure. It actually has a special name. When you have a quadrilateral with a pair of opposite sides that are parallel, then we call that a trapezoid. Okay? A trapezoid. Okay? So definitely a new shape for us today. So I hope you guys enjoyed working with Geogebra Classic. I hope you had fun plotting the points, using the polygon tool, measuring the angles, measuring the slopes of the lines. I hope you found that GeoGebra can be a wonderful tool for analyzing geometry problems in the coordinate plane. So for you guys, when you do your assignment, please feel free to use GeoGebra and help it with your analysis, and be sure to look out for congruent sides. Be sure to look out for angles that are congruent. Be sure to look out for sides that might be parallel by examining slopes of each of your side measures of the polygon, or each of the sides of the polygon. And then take all that information together and come up with your conclusion. Okay? But you guys have a great time on your assignment, and enjoy.